IMO 2025, Problem 5. Alice and Bazza play a two-player game called Inequality, where the rules depend on a known positive real number lambda, on turn n, starting at n equals 1. If n is odd, Alice chooses non-negative x sub n, such that the sum x1 plus xn is less than or equal to lambda times n. If n is even, Bazza chooses non-negative x sub n, such that the sum of squares x1 squared plus xn squared is less than or equal to n. Determine all values of lambda, where each player has a sure win strategy.
We will prove that the critical threshold for lambda is square root of 2 divided by 2.
Bazza's inflation strategy for lambda between 0 and square root of 2 divided by 2. We can say that, among Alice's numbers, there must exist some x that are less than square root of 2, since the opposite quickly causes Alice's linear sum to exceed the limit. Therefore, for sum in all moves, there are x that are between 0 and square root of 1. For every such move, Bazza responds by choosing x2k equals square root of 2 minus x squared, because sum of x2k squared and x2k minus 1 squared equals 2. This keeps Bazza's sum of squares within the limit for all terms. Moreover, it pumps at least square root of 2 into Alice's sum every 2 turns. After 2k turn, t2k is greater than k times square root of 2, which is greater than lambda times 2k. At this point, Alice runs out of moves, and Bazza wins.
Alice's silence hunting strategy, for lambda greater than square root of 2 divided by 2. Alice chooses 0 on all turns initially. Using Cauchy-Schwarz inequality, we can say that t2k plus 1 is less than k times square root of 2, which is less than lambda times 2k plus 1, since lambda is greater than square root of 2 divided by 2. Alice stays safe for all turns. However, the budget of Alice is increasing over time with k. Thus, when k is large enough, Alice only needs to play a single move to force Bazza to fail.